My car is not starting, so I'm going to check my batteries. Batteries are an excellent emergency power source. But do you know what kind of batteries our cars have? It's a lead storage battery. Lead is the heaviest member of the carbon family, which is group 14 of the periodic table. So let's go ahead and meet this unique family of the periodic table. Hello everyone, I am Devabrata Goswami. Welcome to an informative episode of chemistry. Today we will be talking about group 14 elements. We will start with their occurrence and electronic configuration. Then we will move on to their trends in properties like atomic radii and ionization enthalpy. We will also learn the importance and applications of these elements and their compounds. And finally, we will solve important questions in exam decoded section. Let's unravel the mystic chemistry of group 14 elements of P block. Recall that P block consists of 6 groups, group 13 to 18 in the periodic table. The P block is unique because it has all types of elements, that is, metals, non-metals and metalloids in it. Group 14 of the periodic table consists of 5 elements: carbon, silicon, germanium, tin and lead. All these elements are considered to be members of the carbon family. Carbon is the first element of this family. It differs from the rest of the members of this group because of its small size, high electronegativity and non-availability of d orbitals in its valence shell. In this group, carbon and silicon are non-metals. Germanium is a metalloid, which means that it shows both metallic and non-metallic properties. Tin and lead are metals. In conclusion, the general trend is that as we move from top to bottom in group 14, metallic character increases. After seeing the position and metallic character of group 14 in the periodic table, let us study the state in which they occur. The first element, carbon, occurs in the elemental as well as in the combined state. In elemental form, carbon occurs in nature as coal, diamond and graphite. In the combined state, carbon is present as metal carbonates in many minerals and as hydrocarbons and carbon dioxide gas in air. Let's take a very common tool of students anywhere in the world. A pencil. We call them lead pencils because they have non-toxic graphite rather than toxic lead. Lead, being poisonous and harmful, is not used in pencils anymore. This is because if a person swallows lead or breathes in its fumes, lead poisoning occurs. Results can be fatal. It can damage the brain, nerves, and many other parts of the body. Moving on to silicon. Silicon occurs as silica, that is sand, and silicates, which are the constituents of most of the Earth's material. Next element of P block is germanium. Germanium minerals are very rare and exist in traces. These traces are found in some silver and zinc ores and in some types of coal. Following germanium are tin and lead. Tin and lead occur in the Earth's crust in very small amounts. These metals occur as concentrated ores. The chief ore of tin is cassiterite and that of lead is galena. To understand the characteristic properties of an element, it is important to know its electronic configuration. Have a look at the electronic configuration of group 14 elements. In simple terms, their outer electronic configuration is ns2np2. Therefore, we can say that they have 4 electrons in their outermost shell, 2 in the ns orbital and 2 in the np orbital. Let us now discuss the properties of group 14 elements, starting with their atomic and ionic radii. In group 14, the atomic and ionic radii increase on moving down the group from carbon to lead. This is due to the addition of a new shell for each element while going from top to bottom in the group. Now, the question is, what trend do we observe when we compare the atomic and ionic radii of group 13 and group 14 elements? You can log on to our website www.topperlearning.com for the answer. Meanwhile, I will take a short break. But don't go away, because coming up after the break is the answer to many more questions. Keep thinking. Hello everybody, this is Devabrata Goswami and you are watching Chemistry 11. Before the break, I had asked you, what trend do we observe when we compare the atomic and ionic radii of group 13 and group 14 elements? And the answer is, the trend varies as we move from group 13 to group 14. The atomic and ionic radii of group 14 elements are smaller compared to the corresponding group 13 elements. This is due to increase in the effective nuclear charge as we move from left to right, that is, from group 13 to group 14 in the same period. The variation in atomic radii in group 14 affects the ionization enthalpy. You may already know that ionization enthalpy is the energy required to remove an electron from an isolated gaseous atom in its ground state. Now, let us see the trend observed in ionization enthalpy on moving down a group. Ionization enthalpy decreases down the group. However, as you can see, there is a slight increase in ionization enthalpy observed from tin to lead. This exception is due to poor shielding of the intervening d and f orbitals. That was about the ionization enthalpy of group 14. Now, let's compare the ionization enthalpy of group 14 to that of group 13. As the atomic radii of group 14 elements is smaller than group 13 elements, the ionization enthalpy of group 14 elements is more than the corresponding group 13 elements. But what are the common oxidation states shown by these elements? Well, group 14 elements show an oxidation state of +4 and +2. They have 4 electrons in the outermost shell, so they show a common oxidation state of +4. However, the heavier members of group 14 show +2 oxidation state. This is because of the inert pair effect. Wondering what that is? Let me explain. As we move down the group, the intervening d and f electrons shield the ns2 electrons poorly. Hence, the ns2 electrons are pushed inside towards the nucleus. This results in the reluctance of ns electrons to participate in bond formation. This phenomenon is called inert pair effect. The proof of the +4 and +2 oxidation states of group 14 elements is that they combine with oxygen to form two types of oxides, a monooxide with the formula MO and a dioxide with the formula MO2. In monooxides, group 14 elements show an oxidation state of +2, and in dioxide, they show an oxidation state of +4. Okay, we now have a caller who wants to clear a doubt.
Hello sir, my name is Saumil and I want to know, are the dioxides formed by group 14 elements acidic or basic?
Well, I would say it depends. Let me make it clearer. Carbon dioxide, silicon dioxide and germanium dioxide are acidic, whereas dioxides of tin and lead are amphoteric. So, we can say that the acidic character of the dioxides of group 14 elements decreases as we move from carbon to lead. This is because as we move down the group, the size increases, which leads to the weakening of the MO bond. After the reaction of group 14 elements with oxygen, we will move to their reaction with hydrogen. Elements of group 14 form covalent hydrides. The tendency of hydride formation decreases on going from carbon to lead. Carbon forms a large number of cyclic and acyclic hydrides, which are known as hydrocarbons. Silicon and germanium form fewer hydrides known as silanes and germanes respectively. Tin forms two hydrides, SnH4 and SN2H6, out of which the more common one is SnH4, known as monostannate. And the last element, lead, forms only one hydride, plumbane, which is difficult to prepare. The thermal stability of these hydrides decreases down the group. Reason being, as we move down the group, the MH bond weakens. All the physical and chemical properties exhibited by group 14 elements and their compounds leads to wide applications in industries. Let's find out more. Carbon and hydrocarbons are extensively used as fuel. Silicon and its compounds contribute to new technology, as in silicon chips, which has revolutionized the computer and high-tech industries. Tin and lead have more traditional industrial uses. Tin is used extensively in alloys like bronze and solder. Solder has a low melting point and is used in a process called soldering, where it is melted to join metallic surfaces, especially in electronics and plumbing. Now, let's take a short break, but stay tuned, because coming up after the break is the segment you have been waiting for. Yes, it's Exam Decoded. See you in just a bit. Welcome back. I am Deobrato, and today we have been talking about group 14 elements, that is carbon, silicon, germanium, tin and lead. Do you know that a compound of lead, tetraethyl lead, was added to petrol as an anti-knocking compound? But later it proved to be an environmental hazard. That's why unleaded petrol is used now. Looking ahead, a quick recap of today's edition, and then much awaited our rapid fire section. Today we learned that group 14 belongs to P block of the periodic table, and the first element of this group is carbon. Metallic character increases as we move from top to bottom in group 14. the atomic and ionic radii increase on moving down the group from carbon to lead. Group 14 elements combine with oxygen to form two types of oxides, a monooxide with the formula MO and a dioxide with the formula MO2. Now, with that on our fingertips, let's head for Exam Decoded. Welcome to Exam Decoded. As usual, we'll begin with the rapid fire round. The rules are the same as always. I will ask you 5 questions and you just have 5 seconds to answer each one. And every correct answer will fetch you 1 mark. Okay, so your first question right here on your screen. Which of the following oxides is amphoteric? A. CO2, B. SiO2, C. GeO2, D. SnO2. The correct answer is D. SnO2. Now an easy one. Silicon is A. Metal, B. Non-metal, C. Metalloid, D. None. The answer is B. Silicon is a non-metal. Up next, question number 3. Again an average question. On moving down in group 14, which oxidation state becomes stable? A plus 4, B plus 2, C plus 1, D plus 3. The answer is B plus 2. Time for our next question. This one is not so difficult. The atomic radii of group 14 elements decreases on going from carbon to lead. True or false? The answer is false. Atomic radii increases on going from carbon to lead. And now for the last and easy one. The general outer electronic configuration of group 14 elements is Ns2, Np2. True or false? That's true. So let's see how you scored. If you got 5 on 5, you are a high flyer and your preparation is going well. If you got 3 or 4, then you are an achiever. You are almost there, but you need just a bit more effort. Any less than that means you are still a learner and you need to work really hard. But cheer up, help is at hand. Log on to www.topperlearning.com for study material and more questions. This episode, Group 14 Elements, is from the unit The P Block Elements and carries 7 marks. Therefore, it is critical from the exam point of view. The questions generally asked from this topic are very short answer type questions of 1 mark or short answer type questions of 2 to 3 marks, which test your knowledge and conceptual ability. That was about the marks. Now let's take an ideal answer, an answer which can fetch you cent% marks. Consider this. Explain why group 14 elements show oxidation state of +4 and +2. This can come in your exams as a 3-mark question. Well, the ideal way of answering this question is group 14 elements shows an oxidation state of +4 because they have 4 electrons in their outermost shell. The correct reason for this will fetch you 1 mark. The heavier members of group 14 show +2 oxidation state and their stability increases down the group. This is because of the inert pair effect. This statement will fetch you another 1 mark. As we move down the group, the intervening D and F electrons shield the Ns2 electrons poorly. Therefore, the Ns2 electrons are pushed inside towards the nucleus. This results in the reluctance of Ns electrons to participate in bond formation. This phenomenon is called inert pair effect. The correct explanation of inert pair effect will fetch you the last 1 mark. Well, That's all for today. But before I log off, here is something for you to think about. Can you think why carbon is called king of all elements? Keep thinking or log on to www.topperlearning.com for the answer. I will see you again with yet another episode of Chemistry. Till then, it is Devabrata wishing you goodbye.